So, domain and range, day 2. We are going to go over some more information and make sure that you understand it. It's really important we know domain and range well. So, we're going to talk some more about discrete and continuous, and just kind of give you a little more data about that. We talked about it last time. Just want to give you a little more information. So, discrete data cannot be broken down into fractions and decimals. Okay, whole numbers is what we're looking at when we talk about discrete. Discrete data includes things like tickets, students, people, text messages, books. All these things are items that you can count. And just to give you a quick sketch of what discrete would look like, it would be dots on a graph, okay? These are discrete graphs. Whereas continuous data can be broken down into fractions and decimals and whole numbers. It can be anything. There's not restrictions on that. Continuous data includes items you can measure. Okay? Examples are time, temperature, weight, distance, height. And so an example of continuous is, remember, you can do the entire thing. Okay, we could have like all kinds of weird graphs, but it can be done in one thing, and those can look, you don't have to pick up your pencil in order to draw that. It's not just points. Now, limited functions are functions that have restricted domains and ranges. So we saw one of these yesterday. This has a limited function. Well, as far as domains and ranges, if I'm talking about an absolute value, even though this one is continuous, it also has a restriction on its ranges. It can't go below a certain thing. A better example would be what's called a hyperbola, and where it comes down and it goes along. It never touches the axis. We'll see one of these. See how it goes along? It never touches the x or the y axis. And so this is what's called a limited function. It's limited because it will never hit 0 from any place. Okay? So those are just some examples of them, and we'll talk some more about them. So let's talk about this a little more in detail and put some real world things with it. The function below shows the total cost of a school play C depending on the number of tickets bought T. Since there are limited number of seats available in the theater, there are only 150 tickets that can be sold. That's our input. Okay? So, remember, domain is the same as input, x values, and in this case, it's the number of tickets. Okay, that's going to be our input. Can you think of any input values that wouldn't work? Okay, so this is where, think outside the math box. If I'm going to buy tickets, can I have anything can I buy a negative number of tickets? No. So one example that wouldn't work is negative numbers. Okay, you can't purchase, okay, can't purchase by a negative number of tickets. Okay, and this one, if you think about it, is this discrete or continuous? Can I buy a portion of a ticket? Can I buy a fraction of a ticket? No. These are discrete, because you have to buy a whole ticket. Can't buy a portion, a fraction of a ticket. It has to be a whole ticket or no ticket. So what is the domain? What can we plug in? Well, can I buy 0 number of seats? Sure can. Can I buy 1? Can I buy 2? Yes. Okay, now, but what is it limited to? Where is our function limited? We can only buy a total of 150 seats. We can't buy any more than 150 seats because that's all that auditorium that they're talking about here holds. So we can't go more than 150 seats. So our domain is restricted. Okay, so how would we write this as far as in yesterday's notes? Well, this is a discrete one. So this would be a set of numbers. It would not be an interval. Not interval notation. Interval. Sorry. Hold on. Interval notation. It would just be a set of numbers like this. See how these are just numbers. It's not going to be a continuous set. Okay? Now your range, which is your output, or usually your y values, okay, and in this situation I know it's not going to be. Here, would be C of t is our y values, t is our x value, our input. Can also have restrictions, especially when there are limited items that you are selling. In this case, the number of seats available. So that's what limits it. So what is the range in this? Well, if you think about it, let's take our domain and plug it in for just a second. If I plug in 0 to this function, 2 times 0 is still 3. I could still get a 3 out of that. So for this one, 3 is my lowest range value. Now, what can it go up to? Well, our highest number is 150. So where did I get the 3? Well, I plug that in. 2 times 0 plus 3. That gave me 3. Then we can go up by 2's from there. So if I plug in 1, okay, I plug in 1, I'm going to get 5. I plug in 2, I'm going to get 7. So it's going to keep on going up until my very last ticket, which was at 150. So I would plug that in. My 150 is my largest. So I'm just plugging it into the function to find out what I could get for my range. I'm taking my domain, plugging it into my function to find out what my range would be. So 2 times 150 is 300. 300 plus 3 is 303. Whoops, that's supposed to be a 3, not a... Wow, wrote those backwards. So 303. Okay, so we come up with our range. Our range depends on, okay, remember that our range is dependent variable. It depends on our domain, which is our independent variable. So we have to use our domain to determine our range. Okay? Now, what about this function? F of x is equal to the square root. That whole thing has to be under a radical, but it's hard to type that. On this one, we're going to come up with values to see what works. So let's explore. So one of the things that you have to understand is that you cannot take the square root of a negative number, at least right now. Okay, cannot take the square root of a negative number. Yet. Okay, so when you get further on into algebra, in algebra 2, you'll learn about how to take square roots of negatives. Right now, we can't do that. So that's going to restrict our domain. That's going to restrict what we can plug in for x. So we cannot have this be a negative number. Well, think about what would make this 0 is fine. What would make this 0? What could I plug in for x to get 0? I could plug in -5. If I plug in -5, that's the square root of -5 plus 5. That gives me the square root of 0. That is legitimate. I can do that. Okay, I cannot take the square root, though, of a negative number yet. It's important you understand yet. You can, but you haven't learned how to do that yet. So for now, that's going to restrict our domain. And it always restricts our domain as far as determining if it's a function. So when we're talking about functions, we're not going to have negative underneath our radical. So let's just plug in some other values. Well, would -4 work? If I plug in negative 4, I get negative 4 plus 5. That gives me the square root of 1. Yep, I can do that. So what we're finding out is that it has to be that x has to be greater than or equal to negative 5. Okay, and we could stick in 1. Now some will be nicer than others. If I plug in 1, though, I get the square root of 1 plus 5, which is the square root of 6. Okay, the square root of 6 would be square root 6. We don't want to have to graph that. That's kind of a pain. But it still would be a legitimate number. We can come up with that. Could I plug in 2? The square root of 2 plus 5 is the square root of 7. Yeah, I can. It's not a pleasant number, but I can do it. Okay, so that's what my y values would be if I plug them in. Okay, so if we ask ourselves, is there anything that doesn't work? It's just that we can't have a negative underneath, so I can't plug in a negative number. If I plug in negative 6, I'd get the square root of negative 1. We can take the square root of that, just can't do it right now. We don't have that, and when we're talking about functions, we're not going to. So the next question is, does this situation represent a discrete or a continuous one? Well, we can see that it's got to be continuous because we came up with square root 6. So we know that it's continuous. I can't spell today. Continuous data. And the reason is because we even said that we can use x can be greater than or equal to negative 5. So it's not saying just whole numbers. It's saying anything 5 or greater. Okay, what is the domain? We kind of already talked about this. It's going to start at negative 5 and it's going to keep on going. Okay, like that. But because it's continuous, we're going to write it in interval notation. So interval notation, and that's the reason, remember, if it's continuous, we're going to do interval notation. So the way that I'd actually write this is, and it can be anything in between. I can put in a negative 4.5. So it's going to start at negative 5, and negative is included, and it's going to go all the way to infinity. Anything else would work. Okay? So here's another one. Consider the function f of x is equal to x squared minus 1. Let's use a function table to look at this example. Now, these x values were picked for us. So let's just take and plug these in. That's all we're doing. So I'm going to plug in negative 2. F of negative 2. What is that equal to? Oh, that's good practice. Okay, I'll do the first one. Negative 2 squared is 4. 4 minus 2 is 2. Okay? I'm going to pause, and I want you to fill in this table, and you're going to just find f of negative 1, and you're going to find f of 0, and you're going to find f of 1, and you're going to find f of 2. That's good practice, and let's see if you get those answers right, okay? Go. So when you plugged all those in, hopefully you were able to find what those function values were. F of negative 1 is negative 1, okay? F of 0 is 2, f of 1 is negative 1, and f of 2 is positive 2. Okay, so hopefully you were able to find all those on your own. If not, you know where to find us. Now, look at those y values. Now my x values, could I plug in a negative 3? Okay, and if you ever wonder on these, if it doesn't give you a value, you can always pick your own. If I plug in a negative 3, I get 9 minus 2. I get 4. So it's going up. What if I plug in a 3? So negative 3 gave me 4. You can always expand it. You can even pick any number you want. Plug in 10 if you want to. 10 squared is 100. It's going to give me 98. So you can plug in anything you want to for your x values. That's because it is continuous. Now, right now it looks like that it's not continuous. That's because we didn't put any fraction or decimals in. If we would put those in, we would have still gotten a decimal. So this is continuous. Does that ask, oh, whoops, sorry, I'm ahead of myself. This one is continuous. We know that partly because of the way the function is written. No matter what we plug in for x, the output will always be a number that is, and look at this. Look at my lowest number, negative 2. It never goes below negative 2. At 0 is my lowest, and it always has to be that our x values, our y values, our output, always has to be greater than or equal to negative 2. It's not going to go below that. We can plug in even a negative 3, still going to go big, okay, because we have that squared. So is this continuous? Yes. One of the reasons that we know that it's continuous is because that it is a function, It can be written as a function, so it's not discrete. And also we know that we can graph any numbers greater than or equal to 2. We also know it's continuous because we can put fractions and decimals in. Fractions and decimals work. And because all of our numbers are greater than or equal to -2. But the main reason is because we can plug in anything and because we can write it as a function. So what is our range? Our domain is not limited. So our domain, let's go ahead and put both of them down. Our domain was not limited. We went from -3 to 10 just in R's. So this is all real numbers. We write it as -infinity to infinity. The range, though, cannot go below -2. So our range starts at -2 and just keeps getting bigger, so it goes to infinity. Okay? So here are some more examples so that we can just look at domain and range. Most of the time, it's easier to see the limitations from the graph. All of these graphs are examples of continuous data. Okay? So you know what? These are really easy to find out if these are functions or not with our vertical line test. Okay, so we can easily see, does this pass the vertical line test? Sure does. Yep, it's a function. Is this one a function? And the graph that we're looking at is right here. And the graph that we're looking at is right here. And the graph, this graph, I actually talked about before. This is what's called a hyperbola. And it goes up against the two axes, the x and the y axis, but it never touches. Never ever touches. So that's kind of interesting. That will play into our domain and range. Okay, so what's our domain? Do I have any restrictions on my x values? These should actually have arrowheads on them. There are no restrictions on my x values, so it goes from -infinity to infinity. What about my y values? Nope, no restriction. That's the beauty of lines. There's no restrictions on their domain and range. Now look at this one. Is it a function? Put down your vertical line. Yes, it is. Okay, my domain. Now look at where my x values start. Okay, where is that one? Well, we'll just do it with this. Look at where my x values start. They start right here. They don't go anything beyond that. So my domain starts at and is included in, I believe that's a -4. So our domain starts at -4 and it just continues forever and ever, so it goes to infinity. Okay, now let's do that same thing with our y values. See how my y values start here and they go up? I'm going to cover things up if I do it that way. See if I can find a little piece of paper. So, if I'm looking at my range goes from here on up. I'm looking at my range and it goes from here on up. All of this. So what is that y value? Well, that y value is 1 and then it goes, is 0. It's starting at the x-axis. So my range starts at 0, which is included. It's a solid point right there. And then it goes on forever and ever and ever. I know you're going, but it goes over here. But look, it's just going forever and ever and ever, up and up and up and up. So it's going to infinity. Now on this one's very unique. This is a very restricted one, like I was telling you. The only thing that doesn't work is 0 on both the x and the y axis. And that's the reason this one's still a function. That's the thing that's so amazing about this. It never touches this y axis. It will never touch that. And so therefore, yes, this is a function. It actually passes the vertical line test because it will never touch that y axis. As far as the domain, it is everything. So our domain is everything and our range except for 0. Now think of your interval notation. We're going from -infinity to 0. 0 is not included. And then we union with, remember unions, union with 0 to infinity. Okay, that's also what happens on our y values because it's everything but 0. So -infinity to 0, union with 0 to infinity. This tells me it's everything but 0 works. Okay, it's kind of a unique one. Let's look at what your homework is. So the next page in your packet is this. We're not doing that. That would have been great if we were in class. We're not. Oh well. Okay, so this is your homework assignment. It gives you the domain and the range. You've got to actually, it gives you the x and the y. State what your domain and range is. Domain is X, range is Y. Yeah, okay. Then I would use vertical line test to determine my function. You can do it by looking at X values, but it's way more fun by just sticking a vertical line up there and see where it touches. Okay, we give you these values because it's kind of hard to read on these. So you're going to be doing those. Some of those are in your notes, people. Then on the back, evaluate the given functions for the input. So we give you 3 different functions, and then you're going to find the values. So for here, this is f, I'm going to use this function. Whereas here, I'm going to use h. And v, I'm going to use this function. Okay, so 3 different functions. Look to see what functions they want. Here, you're just stating what the domain and the range is. Wait, something's missing there. Hold on. There's nothing missing other than my brain for a second. So it gives you this set of ordered pairs. It wants you to state the domain and the range. It wants you to write the x values and the y values. It wants you to create a map. Okay, and look back at your things, your notes, and I think you'll do fine on this. If not, come ask me in class. That's not a problem. Or ask your teacher. And then you're just going to plot these points on this. That's what you're doing for homework. If you have questions, you know where to find us. Sorry, this was a little long. Have a great day. Bye.